What's that?
I said I also want to get it over, but I also want to start.
Okay, it's time to begin. We discussed grouping yesterday, which you had a few problems on your external assignment that we're dealing with grouping. And today we're going to take sum and difference of cubes. So you still need the same two worksheets out that we had yesterday. I believe it's 9 and 10, if I recall. And in particular, we're going to be looking at rule D and E for this. Okay, here's the general format for sum of cubes. What are the constraints on this? Perfect cube in the front, perfect cube in the back, plus, and eventually, or a minus in the middle. Okay? Now, this falls into the pattern. This thing factored technically would be just the first term alone without the cubes on it. Okay? Here's the other one, by the way. Let me show you a contrast between these two. Now, this is the sum of cubes. This is the difference of cubes. Look at the first term sign. In both cases, the first term sign is the same as the sign of the original problem. But look at the second term sign. Okay? And then the last one is always plus. So these two signs, same, opposite, same, opposite, with a plus always on the end. Okay? Now, there's something different about this. See this piece right here? It looks kind of like our perfect squares term, except it's missing the 2 in both cases. This thing will not factor. The only way to get an answer out of that is to use the quadratic formula, because this thing will generate either a radical, meaning square roots, or an irrational, meaning imaginary number value. Okay? So when you get to this, when you change that to this format, you've gone as far as you can go. Okay? Unless we got it equals 0 out here on the end. All right, here's an example. We have a perfect cube on the front. 8 is a perfect cube. 2, 4, 8. Third power. And x cubed obviously is. 27 is a perfect cube. 3, 9, 27. Okay? And that's on your exponent sheet if you need to look it up. Now then, what we're saying here is this thing really becomes this. What's the cube root of 8? 2. What's the cube root of x cubed? X. Okay, so if we take these and cube them, we would get that. This becomes our first term. Okay,
So that becomes our A.
yeah. That becomes your A. Did I change that one with first and last, or did I just leave it A's and B's on rule C?
First squared minus.
Okay, okay. Well, it doesn't really matter. This becomes your b. The cube root of 27 is 3, so 3 cubed is 27. So here's your perfect cube. Now, based on this, we can go to that rule. In this case, I think it's E, because that's a minus. Okay, here's the rule. Perfect cube minus perfect cube gives you first term minus last term, first term squared plus first times last plus last squared. Well, if 2x and 3 are our first terms, we've got that. So here, I'm just going to have 2x minus 3. Now, do I care if you show this? Not as long as you know this. Okay? As long as you realize that if you see 27, that's really 3 to the third. And if you see 8x squared, you realize that's really 2x cubed. Okay? Now, here's our first term substituted in there. Now, our second term, we take the 2x and we have to square it. We take the a term times the b term, and then we have to take the 3 and square it. And here's what that results in. 2x squared is 4x squared. 2x times 3 is 6x. 3 squared is 9. So here would be your final answer on that problem. Okay. Okay. Anyone else? Okay, what about this one? You're going to need to develop some number sense, okay? That's why I really recommend that you spend some time looking over this page. It will be worthwhile, and more so as we continue in the semester, and absolutely so when you get to 111.
That should be
4.
Yeah.
It's just a list of the powers of different numbers. The most common powers that you might encounter in a math class. Now, do I expect you to have to be able to memorize these? Like in the 2s, go 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 5000. And do I expect you to be able to do that? No, I really don't. Now, I might expect you to be able to go up one at a time and think about it. But what I'm really wanting you to do out of this is I'm wanting you to learn recognition. For example, if you see the number 169, that you recognize that as 13 squared. Oh, that's a number that's a square. That's kind of what I want you to do with this stuff. Okay? So, well, save a whole lot of time. Yeah, repetitive trying. So anyway, that's what I'm talking about on that list off of page 4. Okay, now I lost my place. There we go. Now that I've totally distracted myself. 125, what is 125? If you look on that exponent sheet, 125 is 5 to the third. Okay, so we got a perfect cube right there and a perfect cube with the p's. What about 8? Well, we already decided that it was a perfect cube. So we have the conditions to use formula E. What did I do? Hit the wrong button? I must have. Well, I guess let's go back to that one because I'll want to work it. So what have I got here? I've got 5p cubed minus 2 cubed. Okay, so I write my formula. I remember that it's a minus b, and then a squared plus ab plus b squared. So I'm going to put these in here. 5p minus 2 and 5p squared is 25p squared plus 5p times 2 is 10p plus 4. Done. Okay, you see how I was multiplying those out in my head as I went? And that's okay. Now, if you want to put in that other step they showed you, you can. It's perfectly okay. But I would suggest in doing this so you know what your A's and B's represent.
Sir?
Yes.
Wouldn't it be 25p squared minus 10p?
Where?
With the minus, it's a squared.
With the minus, this becomes plus.
With a plus, it becomes minus. It's the opposite on the trinomial.
Yeah.
Okay.
All right. Any other questions? Okay. I juggled a bunch of slides around today, and it looks like I got a couple of them out of order. Okay. Because I should have more problems than that. Okay, well, here's this one. Perfect cube, 1/8 is a perfect cube, believe it or not. 1/2 times 1/2 times 1/2. Okay. So if you see a number like 8 in the denominator and it's a perfect cube, then in this case, the cube root of 8 is 2. So 1/2 is your B term. So they're going to do this and that. So here's the first part. The second part is the a squared, 1/2 and m, and then 1/2 squared is 1/4. Okay. So let's go on to our next step. Now, what we're going to start doing is we're going to, all up to this point, we've just been pure factoring. Okay. Now we're going to have to take a step farther. We're going to take the expressions that we've been factoring and we're going to set them equal to 0. Okay. Which creates an equation we can solve. Now, why do we set them equal to 0? There's a reason. Whoops. Okay, why do we set them equal to 0? Because where y is equal to 0 are the x-intercepts, and the x-intercepts are what we call the solutions, or the roots is another word for it. Okay. Oh, Math joke. Why did pirates always look for the X on the map when they were looking for treasure? No, because it's the roots. Yeah. I didn't say math jokes were good.
Oh, yeah.
I was just like,
Okay. Oh, well. Write the equation in this form. We've seen the ax squared plus bx plus c before. That's nothing new. All we're doing now is we're setting it equal to 0. Factor it completely. Then we apply what's called the zero product rule. That is, set each factor equal to 0 and solve those two equations. Okay? If you have a square here, you typically will have 2 equations to solve. If you have a cube there, you will typically factor it to 3 factors and 3 equations. And if it was a 4th degree, then potentially 4 places where it would contact the x-axis. Okay, now you can sub to find out if they're correct. Let's look at this one. Well, that one's not in the right format. So the first thing we need to take the 12 over to the other side, like so. So the first thing we got to do is get this thing in the correct a squared plus bx plus c equals 0 format. Now we try to factor this thing. Okay, 2 and 1, probably 6 and 2 on that one. Anyway, we factor it and we get those 2. Nope, we use 3 and 4 instead of 6 and 2. Okay, so that thing factors to that. I'm not going to teach factoring over again tonight. I don't have enough time. So now what we're going to do is we're going to take each of these 2 factors, set them equal to 0, and then solve those 2 equations. Now, why can we do this? If I have 3 times 2 equals 0, then either 3 or 2 has to be 0, doesn't it? And are they both? Could be. Okay, well, that's where that rule comes from. Okay, so take the 3 over to the other side, add negative 3 to both sides. Over here, we add 4 to both sides. And this one we have to continue because we can't leave that 2 there. So do we divide both sides by 2, getting x equals negative 3/2, or x equals 4. Now, if we were to graph this equation, negative 3/2 and 4 would be points on the x-axis that would be graphed if we made an XY table. Okay. Well, we're going to check them. This is just the sub and solve thing. You can look that over. It checks. Now let's check the 4 to see if it works. And it also checks true. So we're pretty much good to go then. Okay, what about this one? Well, this is just a summary statement. Okay. Now, if you leave your answer as, well, let me back up one more step. If you just left your answer like this, or just simply x equals negative 3/2, comma 4, I'm probably not going to take any points if you don't write it that way. Although Alex might. Because Alex seems to like putting everything in set notation. Okay. All right, what about this one? They're not going to work this one for us. So I guess if it's going to get worked, I'm going to have to do it. Well, let's see. Y squared minus 2y equals 35. So I want to take that over to the other side, minus 35, minus 35, and I get y squared minus 2y minus 35 equals 0. Well, my answer down here is going to look like this, right? Based on rule of signs. Okay. I got a 1, 1 there. 7 and 5 give me a difference of 2. Right? So I multiply this way, get a 7, multiply this way, get a 5. Okay. And do my V thing with a subtract. And I do indeed get a 2. Because the 2 is negative, that means the 7 has to be the negative up here. That one has to be the positive. So, kind of crowded this, didn't I? So what are my two terms? X plus 5 and x minus 7 equals 0.
It should be Y.
Okay, y is whatever. They are.
Ah, this is the extended line.
Okay, well, that was bad. So y plus 5 equals 0. Y minus 7 equals 0. Minus 5 minus 5. Y equals negative 5. Y equals positive 7. Okay. All we got is this one little bit of step right here at the end that's different from what we've been doing, right? Okay. Well, here's another one. I guess I better erase. We've got a common term we can factor out first. So at this point, this thing is completely factored. So my two equations become 2x equals 0 and 3x plus 4 equals 0. Well, if 2x equals 0, then x equals 0. Okay? If you had an x squared here, you would still get x equals 0. If you had an x cubed or fourth or fifth, you would still get an x equals 0. Anytime it's a long range or variable, you're going to get an equals 0. And the number will not impact it because, as you see, when you divide it to 0, it goes away. Okay? On this side, on the other hand, we subtracted 4 on both sides. Now we have to divide by 3. So we get negative 4/3. So my solution then is x is 0 and negative 4/3. Whether you write x equals 0 comma negative 4/3 or whether you write it this way. Anything scary about this? Not so far.
You're gonna show us scary.
Maybe. Eventually. You know I always do. Okay, here we go. Totally unconfigured. We got to get this stuff over there. Okay, whoops. Oh, I guess I got to work this one. All right. 9x squared equals 21x. Take that over to the other side, 9x square minus 21x equals 0. I can factor a 3x out of both of those, leaving me 3x minus 7 equal 0. Okay, 3x equals 0. 3x minus 7 equals 0. Here, I divide by 3, and I get x equals 0. Here, plus 7 both sides. 3x equals 7. Divide by 3. X equals positive, in this case, 7/3. So my solution then is x equals 0 and 7/3. And if you want to put that in braces, you can. Questions on this one? My shoes are squeaky today. Okay, this one looks a little bit worse. Does it? I don't know. I don't know. I bet it simplifies down pretty good. Let's see what, well, I've got the slides. I don't necessarily need to do this. They distributed this, got those two. And here's the negative minus 10x they just brought down, and here's those two they just brought down. So now they're going to bring these two over here and combine like terms. Well, I guess they didn't. I guess what they did was they combined these two first. Okay, and got 8x. Now they're going to bring these two over. This 8x, when I subtract 8x on both sides, both of those go away. Okay? So that leaves me, what did I do? Oh, I knocked this thing out of slideshow. Somehow. Go back. Yeah. Okay. Now we're lined up. Okay, so I got the 25 over here. What do we got here? We got a conjugate, don't we? Perfect square on the front, perfect square on the back, minus on the middle. So this one's gonna be 6x minus 5, 6x plus 5. That rule C is really useful. Okay, so we break it down into our two equations. And you get plus or minus 5/6. And I don't care if you write this answer as x equal plus or minus 5/6. And then box it. Now, on your final, you're not going to have answer spaces like I put on my tests. So you need to get in the habit of boxing your work, even now, even though you put it up in my answer blank. Go ahead and box your final answer starting now to just get in the habit for that, okay? Well, that one's kind of a nasty looking one. But is it really? I mean, we gotta distribute this, we gotta distribute that, we gotta distribute that. We gotta combine like terms kind of stuff. Move everything to one side, and then I bet it becomes something fairly simple to factor. Now, do you want me to work this one? Anybody? Yeah? Okay, we can do that. Let me get a red pen. Just keeping things different. I'm gonna leave all that up there, and I'm gonna do my first distribution step. So I've got 10a squared minus 15a for that part, plus 4a plus 4 for that part equals 9a squared minus 6a. Okay. Now let's combine some stuff. These two we can combine. Okay, so 10a squared minus, minus what, 11a plus 4 equals 9a squared minus 6a. So I'm going to take these over and I'm going to take those over. Minus 9a squared minus 9a squared. What does that give me? 1a squared. And these two go away. Plus 6a plus 6a. Those two go away, and I get minus 5a plus 4 equals 0. Okay. Guess what I'm going to use over here? 4 and 1, 1 and 1, right? Rule of signs says I'm going to add. So I get 4 and 1, and I add them, and I get 5. So here's my terms. So x minus 4 equals 0, and x minus 1 equals 0. I guess I should have written this out. X minus 4, x minus 1 equals 0. So I've got this. Take that over to the other side. X equals 4. Take that over to the other side. X equals 1. Done. So as you see, even as nasty as that thing looks, if you just take it one step at a time, okay, it kind of almost gets back to that chain we did the first time. Distribute anything you can, combine any like terms you can, and then you start working it. Well, here's another one. I'm going to run through it. They combined like terms and collected everything on one side this time. They got about 2 hidden steps in there. Take the 2 on the other side and divide by 15. X equals negative 2/15. Okay. In this case, we're only going to have one answer. Why? Because all of the x squares cancel out. When I move this x squared over here, minus 2x squared minus 2x squared. That's why I only had one answer. Okay. Well, there's another one. We actually have two different things we could factor, but I don't know that I want to do that. That would not be profitable. We're better off collecting like terms and just doing the same old stuff we've been doing. Well, what about this one? Uh-oh, I got three terms. 1y, 2y, 3y. This is a cubic problem. This is a cubic problem. Or a cubic equation, I should say. Well, the 2 right here is inconsequential. Okay? Anytime you got a number just stuck out there. Now, notice all three of these are multiplied together. They're not added together. So technically, this 2 impacts all three of them. That's why we can go ahead and deal with it right now. Well, since these are already multiplied together, then that means they are already factored. Okay? There was some bad nasty thing up here that they factored down to this, because when everything is multiplied together, it's factored. Okay? And that's why we can now break this down to our non-entity equation, because that's a non-truth. X plus 7 equals 0, y minus 1 equals 0, and 10y plus 3 equals 0. So we work each one of those three. This one, no solution, so it's a non-player. This one gives us -7, that one gives us 1, this one gives us -3. Okay. Now that you're terribly interested in this, but if we ever wanted to graph that thing, I've got 3 points where it crosses the x-axis, right here, and -3/10 is about right here. Okay. Now, third degree, y times y has a snake type shape. If the leading term is positive, it starts low and ends high. If the leading term is negative, it starts high and then ends low. Okay? If it's an odd-powered set of factors. Well, let's see what the leading term on this thing would be. Negative. That means this thing is going to start high and go downhill. Go low. So that means this farthest left point that I have here, this thing's going to go out that way. And that means this one's got to go this way. Well, what's it going to do between these? It's going to come down here about halfway between these and up to about halfway between those two, and then down like this. And that's what the graph of that thing would look like. Okay. We're going to learn more of those kind of things later. That's not really part of tonight's assignment, but it will be part of the future assignment. Remember how I told you that the quadratics second degree equations always have the characteristic shape up or down depending on the leading term? Well, all of the cubics have the characteristic shape of a snake. And if leading term is positive, it starts low and ends high. If leading term is negative, it starts high and ends low. Okay. Well, what? Okay. Well, here's your answers on this one. Y equals those three values. Well, here's another one. Once again, we're going to have a third degree equation. We're going to have something like that, except 3W positive, 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 positive. So this one's going to start down that way and end up. Okay. I don't think I'm going to work that unless someone wants me to. Anyone want me to? Not particularly. Anybody? Okay. Well, what about this one? Ooh, 4 terms. Factor by grouping. Like you've got a couple on your worksheet. Okay. Well, I can factor a z squared out of this and it'll leave z plus 3. If I look at these two, I can factor a 4 out of this and it will leave z plus 3. So let's break it down this way. So I've got z squared, I'm factoring out of this, so I've got z plus 3 here. Plus, now, if I take all of this, okay, I took this piece first. If I take all of this and I factor a -4 out of it, then I've got z plus, if I took the negative out, 3 equals 0. Okay? Anyone have a question about what I did there? Anybody? Okay. Well, I've got this common term here that I can pull out. Right? What do I got left? Z squared minus 4 equals 0. But z squared minus 4 is a conjugate. It's a difference of squares. Perfect square, minus in the middle. So this piece will break down more. This one won't. So I'm just going to bring it down. But this one breaks into z plus 2, z minus 2 equals 0. Okay, this is going to give me z equals -3. This one will give me z equals -2. And this one will give me z equals +2. So those are my solutions. Do I need to show you why I went from this to that? Okay. Anyone else? Well, here's their work. Looks pretty much like mine, except prettier writing. There's your answers. There's the skip I stepped. Step I skipped. Okay. Now this is pretty much like the last one. Applications. Okay. Let's read. The product, meaning I'm going to multiply together 2 consecutive odd integers. What is a consecutive odd integer? What does the word consecutive mean in English? one after the other. Consecutive, one comes right after the other. So 4 and 5 would be consecutive numbers. Okay, but this says that these are consecutive odd numbers. That means they both have to be odd numbers to start with. So if you have 3, what's the next consecutive odd number? 5. 2 bigger. What's the next consecutive number after 5? 7. 2 bigger. That's where this x plus 2 comes from. Because when you do consecutive even or you do consecutive odd, you jump by 2 numbers at a time. Okay? So if they'd said consecutive even, we still would have used this x plus 2 business. Now, we're going to take our first odd number times our next odd number, which will be 2 bigger than this one. So in this case, we're going to let x be the first one, x plus 2 is the second one, and their product together is 35. Well, distribute this x. And we get x squared plus 2x equals 35. Move the 35 to the other side. Okay. Now, we got to factor this. We've already done this problem once tonight. 7 and 5, right? One of them positive, one of them negative. Which one's the positive? The biggest one has to be positive, so the 7 has to be positive. The 5 has to be the negative inside the parentheses. So we get those. We set each equal to 0. And here are our numbers. Okay. Now, this is saying there are 2 possible sets of numbers for x that would give us a truth. The -7 would work or +5 would work. So let's see. If x is -7, then the next integer is -5. And what's -7 times -5? +35. Let's try the other one. If x is 5, then 2 more is 7. 5 times 7 is 35. Okay, and that's how that works. So you actually have this pair of answers, and you also have that pair, not or, and you have this pair that both will definitely work. Okay. Okay. Quadratic function. What does f of x mean? Y. We've talked about that before. Okay. F of x, or the value of y, will be 0 when we find the solutions. Now, I told you this before. For parabolas, second degree, if the leading term bigger than 0 means it's a positive number, then the thing opens upwards, up and up. If it were a cup, it would hold water. Okay. If the leading term is less than 0, meaning a negative number, then in turn, it won't hold water. We've had that discussion about St. Louis Arch and jump ropes. Okay. And big mast. Makes you hungry. Okay, so what about the x and y intercepts? If we want to find the x intercepts, we let f of x be 0. we want to find the y-intercept, we let these x's be 0. Just like before with lines. Because remember, when you see this, you think y. So here, we're going to find the x-intercept, so we're going to let y be 0. We factor that thing. We solve it. And we get 2 solutions. This thing crosses the x-axis 2 places. At x equals 4 and x equals -3. Okay? Now, let's see what the y-intercept is. Now, based on this equation right here, I can tell you that this one's going to open up that way, right? Because leading term is positive. So I know that. But let's see where this crosses the y-intercept. Okay? So we'll let the x's be 0. Okay? These are the x-intercepts. So let's let the x's be 0 to find the y. This means we're going to substitute 0 for x to get y. Well, you do that. If you let x be 0, it wipes that out, leaves us -12. So what that means then is down here at -12, this loop is going to touch the y-axis. Now, these two are not symmetrically apart from that. So this is not going to be our turning point. Our turning point is going to be about halfway between them. Okay? If you find the value that's exactly halfway between those two, that will be called the axis of symmetry, by the way, which is not really part of tonight's lesson, but it will be a future one. So this thing is going to come like this, through here, down here somewhere, then it'll turn and go that way. It sounded like it was in pain. Now, this point and this point here and here are the same distance from this axis of symmetry. Later on, we'll find out how to find the axis of symmetry. But for right now, you just need to know that these are symmetric. And if I've got this point, this point, this point, I can pretty accurately graph that thing. Okay? Okay, what about this one? Well, they're just asking us to do the same thing. The y-intercept is that, and you get these two x-intercepts. Okay, so what would this graph look like? Well, here's my axis. Where are my points? -6, way out here, and -2, we're about here. What is my y-intercept? +12 up here. Well, that's not possible. So there's something that's wrong.
No, because your axis of symmetry would be way further down.
No, it isn't wrong. This thing is a positive, right? So it's opening upwards. Okay. Now, how far down does this go? Well, since that's 2 and 6, halfway between 2 and 6 is 4. We could substitute 4 into that equation, maybe 4 into that equation, and find out how far down it goes. if we were really interested. Okay. Let me erase. Looks like I have a random line out here somewhere. Okay, domain. I'll just let you read that. It's a whole lot of gobbledygook. Okay. What is the domain? It's the set of possible all X values that you could have in the problem. Now, it's real easy to tell from a graph. Maybe not as easy to tell from an equation. But I will tell you this much. Every line has a domain with one exception, and that's a vertical line. Okay? Every line except the vertical line has a domain from negative to positive infinity. Every quadratic, that's not a quadratic, has a domain from infinity to infinity. Okay? Now, there are some functions that don't have a domain infinity to infinity. Okay? And some inverse and some things. We're going to come up with something on this in a little while called the vertical line. But this one doesn't violate the vertical line. But this one does go from infinity to infinity, doesn't it? So do most odd-powered equations. Most. There are a few exceptions. Okay? But there are some things like square roots and some other stuff that you have limited domains in. Okay? Well, that's the end of this chapter. I do want to show you this, even though you're not going to be tested over this. Rocket science. Anybody ever see the movie October Sky? Yeah. What we're talking about right here is the formula that kid used to find out they didn't set the forest on fire. Okay. Anytime you just see a 16 or a 32 in a square, you're talking about the force of gravity. Okay. Now, this is the rest of this thing. It's given by, here's the general function that relates to the rocket's height, which is t in feet, to the time after launch in seconds. So we're comparing height to time. Height on the vertical axis, time on the horizontal axis. Now, you can read all of that, but let me get to the pictures. They've solved it. They get these numbers, or those numbers. Now, they're going to show a graph here in a minute. Here's the graph. This rocket left at 0 elevation at 0 minutes or 0 seconds. After 3 seconds, this rocket was 750 feet high. After 6 seconds, it was roughly 1,100 feet high. Its maximum height, okay, was approximately 1,300 feet. And that maximum came at 9 seconds of flight time. Then after that, it starts to come back down. Okay. Eventually hitting the ground after 18 seconds at 0 elevation. Now, that's rocketry 101. Now, did you ever see the movie Hidden Figures?
Yeah.
About the ladies who work for NASA? Okay.
I've heard of it, and
What they were talking about, the big drama in that movie was, here's the Earth, and that satellite traveled in what's called an elliptical path around the Earth, egg-shaped path. And what they had to do, and there are equations for elliptical paths like this. And you're going to have x squares and y squares both in it. Okay. Now, what they had to do was had to figure out how to alter this equation into this equation to land. That's what they were talking about. And they had to come up with the new math to do it that no one had done before. Okay. Now, some of you, I'm going to use a quote. I wish I were the author of this quote, but I'm not. Some of you may go into mathematical fields, engineering, whatever, okay, or even construction. Some of you may go into medical fields. Did you know that a parabola is how you measure the radiation dosage on a patient in radiation therapy? Did you know that a parabola is how you track how much dosage they have in their body with chemo or just a simple aspirin? Well, that's kind of a specialized term. But anyway, what goes up got to come down. Now, how soon can you take the second pill? Well, if you take the pill while you're at the peak here, peak of the first one, you're going to go up here into the danger zone. But if you take the pill after you're starting to come down and you take it right here, it's going to bump you up probably higher than the first one. But how high is safe? And they've plotted that over years. So when they say only take every 6 hours, they're wanting to keep you from overdosing. And it's all based on mathematics. Okay. Now, it's all done in computers too. Now, not when I was in college. We had one computer on the entire campus, and it filled a room this size. They had to have huge air conditioning units to keep it from cooking itself. And you punched physical holes in cards for inputs, fed them into the machine, and came back 6 hours later to see if you made even the slightest error. Whereas these calculators and phones that you guys have in your pockets and in your purses and hands, they're much more powerful than that entire computer was. But that's what they sent people to the moon with. And that depiction in Hidden Figures is very accurate of what happened, including John Glenn's lack of faith in the computer, which was justified at that particular point, because garbage in, garbage out, and someone put a wrong number in. Okay, well, here's another one where if you drop something off of a building. Okay, and you can do all kinds of things. Now, we're going to stop with that, and we're just going to talk for a couple of minutes in general terms. Let me get this out of the screen. Oh yeah, I made some changes. Better save them. There we go. let's talk just for a little bit about what the future is ahead of you. Okay, this is going to be different for my online class. Now, for my in-person class, Monday, Tuesday, Thursday class, at the beginning of class on Thursday, we will grade your handout packet. To my online class, if you want to watch that, you can, although yours is not due until Monday. And you have to email yours to my online class. Now, after we finish going over that, then we're actually going to begin on exam 3 material. Okay? And then you will have your test on Monday. And that's all we're going to do on Monday. You can come in early just like you did last time if you choose to. For the online class, your test is Saturday. Oh, that writing on my forehead. True Wichita State fan, right? For my online class, your test is Saturday the 8th, and it'll be in room 104 in Joybara Hall and at 1 o'clock. So you'll need to be there unless you've made prior arrangements with me. That said, let's get out of here a few minutes early tonight. So I think